2022 GCE Mathematics Paper 1 Question 11A. Given that universal set is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Set A is the prime numbers. Then set B, multiples of 3. List A union B complement. So now, the first thing we need to look at the elements that are in B and also that are in A. So here, this is set A. So prime numbers. So what are prime numbers? Prime numbers, these are numbers that are divisible by 1 and themselves. So the number that is divisible by 1 and itself, it is a prime number. So for example, 2 is divisible by 1 and itself. So 2, it is a prime number. 3, it is a prime number. 5, it is a prime number. 7, it is a prime number. 9, it is not a prime number because 9, we have 3 can go into 9 without leaving a remainder 1 and 9 itself. So these are the only prime numbers that we have. Then we have set B, which are multiples of 3. So how do we find the multiples of 3? It is very simple. For example, if I say 1 times 3, it is 3. 2 times 3, it is 6. 3 times 3, it is 9. 3 times 4, it is 12. So these are the multiples of 3. So these are the multiples of 3. So now multiples of 3 in this set we have 3, 6, and 9. So 3, 6, and 9. So these are the multiples of 3. So from here, let's look at the elements that are in both set A and set B. So we have 3. So we have, this is the Venn diagram. So we have the universal set, set A, set B. So we have set A and B, we have 3. So here we remain with 2, 5, and 7. So here we remain with 6 and 9. So those are the elements which are not in A, but they are in the set B and the universal set. So now let's look at the elements which are not in set A and in set B, but they are in the universal set. So we have 1. So 1 is not part of these elements. So we have 1. So 2 is there, 3 is there, 4. 5 is there, 6 is there, 7 is there, 8. 9 is there, 10. So when we say list A union B complement, it means the elements which are not in A and in B, but they are in the universal set. So the answer is 1, 4, 8, and 10. So these are the elements which are not in A and in B, but they are in the universal set. Part B, on the diagram in the answer space, draw the triangle Q, the image of triangle P under a reflection in the line y is equal to negative x. So on the diagram in the answer space, draw triangle Q, the image of triangle P under a reflection in the line y is equal to negative x. So y is equal to negative x, it is a mirror line. And this y is equal to negative x, it is a special line. So this is where y is equal to negative x passes. So this line, it passes through 0, 0, negative 1, 1, negative 2, 2, negative 3,3, negative 4,4, 1, negative 1, 2, negative 2, 3, negative 3, 4, negative 4. So this is y is equal to negative x. So under a refraction, so this is a diagonal line. So for us to be counting the points, we need to be counting diagonal. So this is the point. So this point, there is no need for you to be going like this. No, you have to be going diagonal of this box, because this line is also cutting diagonal. Remember that the point is moving perpendicular to the mirror line. And remember that this is the object, the image, it will be on this side. So under refraction, each point will move from the image to the mirror line. The distance should be equal from the mirror line to the image. So let's count. We have 1 and half. Half, 1. So this is what we have. So here we have 1, 2, 3. So here we have 1, 2, 3. So this is what we have. And then there is also this point 1, 2. So from here going the other side, we need to count 1, 2 as well. So these are the 3 points. So now, so this is Q. So that is our answer. That is diffraction. Number 12, a piece of wood measures 25 centimeters long. Find the upper and lower limits. So how do we find the upper and the lower limits? Number 1, we need to start with what we call the absolute error. So how do we find the absolute error? So this one, it is nearest to centimeter. So that simply means that this is how we can calculate the absolute error. So absolute error is equal to 1/2 times to the nearest centimeter, which is 1 centimeter. So which is 1 centimeter. So when I multiply, I'm going to have 0.5 centimeters. So this is the absolute error. So for us to find the upper limit, we need to add with the absolute error. For us to find the lower limit, we need to subtract with the absolute error. So upper limit, so I'm going to say 25 plus 0.5. The answer is 25.5 centimeters. This is the upper limit. For the lower limit, we subtract. So 25 minus 0.5. So the answer is 24.5 centimeters. So this is the lower limit. So B, how do we calculate the percentage error? So percentage error is equal to absolute error over true value times 100%. So percentage error is equal to absolute error, it is 0.5 over true value is 25 times 100%. So 25 into 25, 125 into 100, that is 4. So 4 times 0.5. So the answer is 2. So 2% is the percentage error. Number 13, given that f of x is equal to x minus 4 and h of x is equal to 2x plus 3, find h inverse of x. So part A, so we are looking for the h inverse of x. So I'm going to use h function. So h of x is equal to 2x plus 3. So step number 1, to find the inverse function, let h of x be y. That is step number 1. Then step number 2, make x the subject of the formula. So this 3, it will go inside. It is going to be negative equals 2x. So over 2, 2 goes. So x is equal to y minus 3 over 2. So we have made x the subject of the formula. The next step is replace y with x. So h inverse of x is equal to, where there is y, we replace with x, minus 3 over 2. So that is the inverse of h. Then B, find h inverse of 5. So for us to find h inverse of 5, we need to use h inverse of x, of which we have, this is our h inverse of x. So h inverse of x is x minus 3 over 2. So h inverse of 5 is equal to, where there is x here, we are going to substitute 5. So it is going to be 5 minus 3 over 2. H inverse of 5 is equal to 5 minus 3. It is 2 over 2. So H inverse of 5 equals 2 into 2, it is 1. So that is our answer. Part C, find h f of x. So this is a composite function. A composite function, it is a combination of two or more functions. So in this case, there is a combination of h function and f function. This means that f function has been swallowed by the h function. So h of x is equal to 2x plus 3 and f of x is equal to x minus 4. So this means that where there is x here in h, we are going to substitute with the f function. So f function has been swallowed by h function. So f of x is equal to 2, where there is x here, we substitute x minus 4 plus 3. So f of x is equal to 2 times x, 2x, 2 times 4, 8, plus 3. So f of x is equal to 2x. These two are like terms. So negative 8 plus 3, we are going to have negative 5. So that is f of x. Number 14, in the following diagram, P, Q, and R are 3 points on level ground. The bearing of P from Q is 228 degrees. Angle QPR is equal to 72 degrees and R is due south of Q. Find the bearing of A, Q from P. How do we find the bearing of Q from P? So you need to go on the last letter, which is P. So this is P. Then from P, you draw a true north. Now in this case, we already have a true north. So I'll just extend it like this. Okay. Then we are going to move from P to Q. So this true north becomes your P. So we'll move from here to Q. So this is line Q. So from P to Q. So this is the angle that we are looking for. So remember about the alternate angles. So if this is a true north, this is a true north. So these two, they are parallel. So this angle X is equal to this angle X. So these two angles, they are alternate angles. So alternate angles, they are equal. So if this is Y, this is also Y. Okay, so it is in this case, this angle, it is the same as this angle. Okay, so this one, it is making a Z. So how do we find this angle? If I find this angle, then I have this angle. So remember that this is a straight line. A straight line adds up to 180. So from here to here, it is 228. So I'll say 228 minus 180. So 8, this is 4. So the answer is 48 degrees. So this is 48 degrees and this is 48 degrees. So the answer is 0.48 degrees. Remember that bearings are calculated in 3 digits. Part B, find the bearing of P from R. So you need to go on R, which is the last letter here. So this is R. R, we already have a true north. So here I just have to extend it like this. Then I'll move from R to P. So where is P? This is P. So this becomes my R. So from here to here. So this is the angle that we are looking for. And this is a straight line. A straight line adds up to 180 degrees. Remember about the alternate angles. So this angle is equal to this angle. So this angle, it is 48 plus 72 degrees. So it will be 180 plus 42 plus 72, 120. So we have 120, 48 plus 72, that is 120. So the answer is 0, 0, 3. So we have 300 degrees. 15a, a line passes through the points A, negative 2, 5, B, 0, y. Given that the gradient of the line AB is negative 3, find the coordinates of B. So coordinates of B, already we have a 0 here. So now what have we been given? So what we've been given, it is gradient. So since gradient is given to be negative 3, we are going to use the formula for gradient. So gradient is equal to y1 minus y2 over x1 minus x2. So gradient is negative 3. So where there is m, I'll put negative 3. So this is x1, y1, x2, y2. So y1 is 5 minus y2 is y. X1 is negative 2 minus x2, it is 0. So negative 3 equals 5 minus y over negative 2 minus 0, it is negative 2. So from there, I cross multiply. So 1 times 5 minus y, it is 5 minus y equals negative 3 times negative 2, it is positive 6. So from there, I'll correct the like terms. This remains as negative y equals 6 minus 5. So negative y is equal to 6 minus 5, that is 1. So the value for y is equal to. So now the question is, find the coordinates of B. So where there is y, we are going to substitute the value of y, which is. So coordinate B is 0, comma, where there is y, we substitute t. Part B, in the diagram, ABC is a straight line. ABC is a straight line. Angle BCD is 90 degrees. And tan ABD is equal to negative 3 over 4. So calculate the length of BD. So BD. So remember that tan theta is equal to opposite over adjacent. So since tan B is given, which is angle B, okay, opposite is 3, adjacent it is 4. So remember that tan A BD, which is the exterior angle, that is the reason why it is having a negative. Now tan DBC, it is a positive, which is 3 over 4. And this one, it is a negative 3 over 4. So if you have the interior angle as a tan, the exterior is negative in terms of the fraction as given there. So now remember, where this angle is facing, it is called the opposite. So the opposite is 3. And then where 90 degrees is facing, it is called the hypotenuse. And the remaining one, it is called adjacent. So adjacent, it is 4. So how do we find the length of BD? So to find BD, I've got 2 adjacents. I'm going to use Pythagoras theorem. So BD squared is equal to BC squared plus CD squared. So BD squared is equal to BC, it is 4 squared. CD, it is 3 squared. So BD squared is equal to 4 squared, that is 16. 3 squared, that is 9. So BD squared is equal to 16 plus 9, that is 25. Then we introduce the square root, both sides. Square root and square goes. So BD is equal to the square root of 25, that is 5. So there I won't put the units because I don't know if it is in centimeters or kilometers or meters. 16A, 2 cylinders A and B are geometrically similar and the ratio of their heights is m to 4 respectively. Given that the areas of A and B are 144 centimeters squared and 256 centimeters squared respectively, find the value of m. So we have been given the ratio of heights, which is m to 4, and we have been given area ratio of A and B, which is 144 and 256. So 144 to 256. So that is the area ratio. And then we have the ratio of heights. So the first thing that we are going to do, we are going to change this 144 and 256 ratio area. We are going to convert it back to the water, to their original heights for us to find the value of m. So we are going to introduce the square root. So the square root of 144 and the square root of 256. We are changing from area ratio to their original ratio heights. So the square root of 144, it is 12. The square root of 256, it is 16. Okay, and then we have m to 4. So from there, I'll just cross multiply. 12 times 4, we have 12 times 4 equals m times 16. So remember that we are solving for m. So I'll divide throughout with 16 over 16. 16 goes. So m is equal to, remember that this is paper 1. You are not required to use a calculator. So I'll say 4 into 4, it is 1. 4 into 16, it is 4. 4 into 4, it's 1. 4 into 12, it is 3. So the value for m, it is 3. Part B, the diagram below shows a square-based right pyramid with an axis AB. Describe fully the symmetry of the pyramid. So how do we describe fully? So in this case, we need to describe the rotational symmetry. We need to describe the rotational symmetry, and we also need to describe the planes of symmetry. So how do we find the order of rotational? So the order of rotational, remember that this one, it is a square based. It is a square based. Okay, so how is it a square based? So this side is equal to this one, is equal to this one, is equal to this one. So we are going to say 360 over, when this one rotates, for it to appear to the original state, it will rotate 90 degrees because it is a square. All the sides are equal. So this side is equal to this side, is equal to this side, is equal to this side. So when I rotate 90 degrees, it will appear the same. So I'll say 360 over 90. The answer is equal to 4. So 4, it is the order of rotation. So now, what about the planes of symmetry? So the planes of symmetry, for it to rotate and go back to its original state, it has 4 planes. So we have 1, 2, 3, 4. So meaning it has 4 planes of symmetry. So the order of 4, and then the rotational, and then the planes of symmetry 4 as well. So rotational order of 4 and planes of symmetry 4. Question 17. In the following diagram, A, B, C, and D are the points on the circumference of the circle. Center O. BD is the diameter. BD is the diameter. So BD is the diameter. AD is equal to AC. So that is an isosceles triangle. ACD is an isosceles triangle. Why? Because these two sides are equal. Find part A, BAC. BAC. So BAC. So we are looking for this angle. So how do we answer that angle? So remember the properties of circle theorem. So this property, it says that angles suspended on the same segment, they are equal. So this 22 is equal to this angle. Why? Because they are suspended on the same segment. So BAC is equal to 22 degrees. B, find CBD. CBD. So this angle. So how do we find this angle? So CBD. So remember that BD is the diameter. So there is a property that states that an angle on a semicircle is right angle, meaning it is 90 degrees. So BD is the diameter. So if BD is the diameter, then this is 90 degrees. This is 90 degrees. So this is a right angled triangle. So we have 22 degrees here. So this is 22 degrees. So how do we find this angle? So remember that a triangle adds up to 180 degrees. So I'll simply say angle B plus 22 plus this angle C, which is 90 degrees, is equal to 180 degrees. So angle B is equal to 180, 22 plus 90, I'm going to have 112. So 112, it will go this side, it is going to be negative 112. So angle B is equal to 180 minus 112. The answer is 68 degrees. So we go to part C. Find ACO. ACO. So this angle. So this is the angle that we are looking for. So remember that this is 90 degrees. Okay. But the angle that we are looking for, it is this one. And the other thing that you need to understand, that triangle OCD is an isosceles triangle. This is a radius and this is a radius. So this radius is the same as this radius. So this angle 22, it is also the same as this angle 22 degrees here. So the angle that I'm looking for, it is this angle. And again, ACD is an isosceles triangle. These two sides are equal, and these two angles are equal. So if I have this angle it is very easy for me to find this angle. So remember that we have this angle. So this angle, it is 68. So where is that 68 coming from? So this is 68 degrees and this is 68 degrees. So angles suspended on the same segment, they are equal. So we have this angle 68 degrees, okay? And this angle also, it is 68. So now part C, this is how we have to do it. So how do we find this angle? So let's say this is x, this is also x. Why? Because the two angles are the same. So we'll say x plus x plus 68 is equal to 180. So x plus x, it is 2x is equal to 180 minus 68. So 2x is equal to 180 minus 68. We are going to have 112. So over 2 over 2. So x is equal to 2 into 112. So we are going to have 56 degrees. Okay, so x is 56 degrees. So this simply means that this angle from here to here, it is 56 degrees. So for me to find this angle, I just have to subtract 56 minus 22. I will remain with this angle that we are looking for. So 56 minus 22, the answer is 34 degrees. So that is our answer. Number 18, y varies directly as x and inversely as the square of z, and y is equal to 8 when x is equal to 4 and z is equal to 1. Find the value of k, the constant of variation. So the first thing that we are going to do, we are going to form an expression. Okay. So remember that y varies directly as x and you introduce multiplication. Inversely as the square of z. Inversely as the square of z. So meaning it will be z squared. So from there now, I'll say y. I'll introduce the equal sign. When I introduce the equal sign, I'll introduce k, the constant. So k times 1, it is k times x, it is kx over z squared. So find the value of k, the constant of variation. So do we have the value of y, x, and z? Yes, we have been given in the question y is 8, x is 4, and z is 1. So where there is y, I'll substitute 8. K times where there is x, I'll substitute 4. Where there is z, I'll substitute 1. So it will be 1 squared. So 8 is equal to k times 4, it is 4k. So 1 squared, that is 1. 1 into 4, it is 4. So over 4, 4 and 4 goes. So k is equal to 2. So 4 into 8, it is 2. So part B, find the value of y when x is equal to 9 and z is equal to 3. So remember that we have this is what we call variation equation. So that is variation equation. So we have the value of k, which is 2. So y is equal to, where there is k, we substitute 2, x over z squared. So find the value of y when x is 9. So where there is x, I'll substitute 9. Where there is z, I'll substitute 3. So y is equal to 2, x is 9, z is 3, so it will be 3 squared. So y is equal to 2 times 9, it is 18, over 3 squared, it is 9. So 9 into 18, it is 2. So that is the value of y. So part C, find the values of z when y is 3 and x is 54. So remember, we have the variation equation, which is 2x over z squared. So that is the variation equation. So y is given to be 3. So where there is y, I'll substitute 3. Where there is x, I'll substitute 54 over z squared. So I'll cross multiply. So 3 times z squared, it is 3. Z squared is equal to 2 times 54. So remember that this is paper 1. Okay, you don't need to use a calculator. So I'll say over 3 over 3. 3 goes. So z squared is equal to 3 can go into 54. So which is 3 into 5, it is 1, remainder 2. So 3 into 24, that is 8. So 3 into 54, it is 18. So z squared is equal to 2 times 18, we are going to have 36. Z squared is equal to 36. So now, how do we get rid of the squared? It is by introducing the square root both sides. But this side, we say positive or negative. So the square root and the squared goes. So z is equal to positive or negative. The square root of 36, it is 6. So we have now two values of z. So z is positive 6 or negative 6. So 19a, solve the equation x to the power 1 over 3 is equal to 9. So these are indices involving equations. So in this case, the variable is a base and we want the value of x. So I must get rid of the power, which is 1 over 3. So how do I get rid of this power 1 over 3? It is by introducing what we call the inverse of 1 over 3. Okay, the inverse of 1 over 3. So the inverse of 1 over 3 is a number that we can multiply to 1 over 3 and gives us 1. Okay, so this side I must remain with the power 1. So it is 3. So now I'll also multiply 3 this side. Okay, so 3 and 3 goes. I remain with x to the power 1. So 9 to the power 3, it means 9 times 9 times 9. So any number or letter to the power 1, it is the number or letter itself. So 9 times 9, it is 81. So 81 times 9. So we are going to have 729. So this is the value of x. In the answer space below is an incomplete flowchart for calculating the height h of a cylinder given its volume V and radius R. Complete the flowchart. So in this flowchart, our interest, it is to calculate the height of a cylinder of which volume is given and the radius is given. So the most important thing here, you must know the formula for the volume of the cylinder. Then it will be easy for you to answer this question. So volume of a cylinder is equal to pi r squared h. That is the volume of a cylinder. So now the program, you start the program. The next thing that we are going to do, it is the inputs. Okay, so where you are going to input what you have, V, R, and H. So these are the values that we are going to input. Remember that pi, it is constant. So there is no need for you to input the pi because pi, it is constant. So enter V and R. Okay, we want H. So I'm not going to enter H. We want the value of H, which is the height. So I will not enter this one. I'll just enter the value for V and the value for R. Then from there now, I'm going to write the formula for the volume of the cylinder. So V is equal to pi times, you use the star. That is a symbol for multiplication in computer programming. Times r squared, you say r to the power 2, okay, times h. So that is what it is. Then you print h and you stop the program.